Okay, so I'm going to be talking about 5ESS, which is the number 5 electronic switching system, DMS, which is the digital multiplex system, another switch manufactured by Nortel, and DataKit, which is a virtual circuit switched protocol similar to X25, which the telcos, especially the RBox in the United States, use to tie the switches in with the rest of their network. Like I said, 5ESS and DMS are both Class 5 telephone switches. Class 5 telephone switches basically mean they're in like a CO. They're huge. They're landline-based telephone switches. They have like five nines uptime, very reliable. POTS is way better than voice over IP for quality, but it's very difficult to maintain, and that's why a lot of the telcos are moving away from, the Class 5 telephone switches and trying to move towards voice over IP. So 5ESS is now manufactured by Lucent Alcatel, or Alcatel-Lucent, sorry. Previously, AT&T stands for the number 5 electronic switching system. DMS is from Nortel, and DataKit is actually from Bell Labs, and has 2 versions: the ISN version, which is the Information Services Network, and the VCS, which is the Virtual Circuit Switched Network. And they're slightly incompatible. For what I've been told from Dennis Ritchie is some type of marketing or sales reason having to do with Bell and their limitations to sell technology. So yeah, this talk will not focus on cellular switching, even though the 5ESS switch does handle cellular calls. So we'll simply talk about using, if you had access to a 5ESS switch or a DMS 100 switch, what you could do with it. And it will expose a lot of the internals that have not been talked about and written about in previous articles. Like firm grasps, 5ESS from top to bottom. I don't know if any of you have read that. It's in an older FRAC issue. Is anybody familiar with that? Oh, okay. I'll also use a training simulator of the 5ESS, which I think you guys caught a glimpse of with that black window before my slides came up. I was planning on using an actual emulator, which I have, for the very compact digital exchanges. They actually have Lucent sells a OEM version of Solaris 2.6 that runs on Spark that comes with a 3v2.1 emulator, which is the platform that 5ESS runs on. Unfortunately, I have the emulator, I don't have the 5ESS and DMERT, which is the OS, dump. So I'm not able to use that, but the simulator should give you a good idea of the recent change and verify interface and the trunk line and workstation interface. Not nearly all of the functionality is there because it's a training interface. So the 5ESS has 3 modules. The administrative module, which is what we'll be talking about. It's based on Unix. I believe an early version of SBR3, at least VI, when you're on the switch, if you do a :version, says SBR3. And to all other appearances, it seems to be about that era of Unix. There's still setuid MV and setuid MKdir because there's no system calls for mkdir or rename. So, of course, MV has to use link, which is a privileged system call, and mkdir has to use mknod to make a directory, which is also privileged. I'll also talk a little bit about, not really FSDB, I should have taken that up there, but GRASP, which is the generic debugger for 5ESS, and the Western Electric 32K assembly language, which is the processor that runs 5ESS switches. So, like I said, the AM is Unix-based. There are user processes and kernel processes. They both show up in PS. I don't believe my memory is dated a little bit, but I don't believe you can tell the difference unless you know the name of the process. There's no like flag or anything that says this is the kernel process. And the PIDs are extremely long. They're like, I believe they're 32-bit, but they're like all in the higher range of the 32-bit range, which is quite interesting and weird. So it runs on the Western Electric 32K or 32100, which is known as the 3B21D. The 3B20D is the former. It's a CISC CPU on which the stack grows up. So it's actually one of the only platforms besides PA-RISC that I'm aware of where the stack grows up. The D stands for duplex. They actually do sell, or did sell, a 3B20S, which was simplex, and it was a general purpose Unix system. Every piece of hardware on the 5ESS is duplicated for redundancy. So, also the output of a uname-a is quite weird. It's in, those brackets are there, and that's the output. So it's just the processor type. So I was talking about kernel processes earlier. There's special commands for dealing with those. You can't use the regular kill command. There's this kp kill command for terminating kernel processes. It is a real-time OS, I believe soft real-time because it's Unix, but perhaps I'm wrong there. It could be that the kernel processes are scheduled, real-time, and that the userland stuff is not scheduled with any priority over that. So it's actually possibly a microkernel architecture because of the appearance of kernel processors. I haven't actually found this out, but I have a source in the development group, the 5ESS development group. I have a good contact there, and I'm trying to ask him about the kernel a little bit more. So I'll move on to the next slide. I've got a lot of 5ESS slides and not a lot of DMS and datakit slides because 5ESS was just, I could do a whole day on 5ESS and a whole day on DMS. So the 5ESS has terminals which are known as channels. T2IA and B are the master control channels. They give you recent change and verify access, as well as shell access. T2IW also gives you recent change and verify access, as well as shell access because you are in the craft shell. And from the craft shell, as I'll show later, you can escape and escalate your privileges to root. T2IJ through O are the TLWS, which are more limited channels. They have access to receive or recent change and verify, and no access to the craft shell. I actually have in the simulator is what you'll see is a TLWS terminal. So this is a good quote from Firmgrass. Although it is a Unix system, I mean, of course, you're on a TTY. You can execute a process on any TTY, and it's going to pretty much behave the same unless there's code in there that makes it not behave the same. But on the 5ESS, there are channels, and like on the TLWS channel, there's very little user input. There's no way to really escape to execute any other process. If you happen to be root and killed the process running on another channel and then instantiated your own process with redirection to that TTY for all three standard I/O file descriptors, then effectively you could change the channel. But it's not a TV. So the craft shell is the main interface when you log into a 5ESS. If you're doing recent change and verify, which is recent change and verify, I should explain, is like service orders or changing the number of your line or adding three-way call line, adding three-way calling, or call forwarding or something like that. It's known as servord on the DMS. So the craft shell commands, the input and output commands. The input commands are documented in an AT&T manual 235-600-700, and the output messages are in 235-600-750. They used to just sell these to anybody, but after 9/11, they, I guess, consider everything critical infrastructure. And they want you to be a client of theirs or customer. So they only sell them to RBox and CLEX that own the actual hardware. Recent change and verify can be done fully from the craft shell. However, nobody does it this way. It would probably arouse suspicion because everything is printed on the receive-only printer, which is referred to as the ROP in telco terminology. And the manuals for the input messages for doing recent change and verify, doing service orders on the craft shell directly without using the AppRC menu, which I'll get into later, is, they're pretty much unobtainable. Unobtainium, I think I said. So the craft shell interface works like this. You enter command followed by a exclamation point. If it's a command that executes immediately, it will execute immediately. If it's something that can be executed as part of a group of commands, it won't be executed immediately, and it will be executed as part of a batch kind of job when you execute another command and terminate it with a semicolon or a return, which is the same as a semicolon. So if you ever see this, you have a lot of power. A lot of power. You have the power to wiretap calls. You have the power to forward numbers. All those modem carriers you found, forward them to another modem that you have access to and throw up a fake login banner. Great way to get into to other systems. Not like I ever did anything like that. So, some example commands. The first thing I would always do when being on a 5ESS is inhibit the history because I don't want the commands to be logged. Even though they're going to the ROP, that's another source that they go to if you don't inhibit it. You can also inhibit ANI for a specific trunk group, which means if you use that trunk group, which could be AT&T or another long-distance carrier, no ANI is coming to them, so they have no idea who to bill it to, so you get an ANI failure, so your calls are free. You can also inhibit ANI on the entire switch and free calls for everybody. I don't recommend that. So the output from craft shell commands is either OK if something good happened, or PF, which means printout follows, which is also something probably good. Your command succeeded. NG means no good. So like I was saying earlier, recent change or recent change / verify are their telco terminology for just service orders. The service orders actually are not entered directly on the switch by personnel. Nobody does that, really. They're entered by a system called March, which picks them up from another system you've probably heard of that used to be called Cosmos and was then known as Switch, all capitals, and is now known as FOMS. And it runs on, FOMS runs on UTS. It's an Amdahl mainframe running UTS, Unix, System 5, release 4.5, or if I remember correctly. So yeah, it's like changing a directory number or creating or shutting off subscriber telephone service. Any kind of service order, anything you call up your telephone company and ask them to add or remove from your line is recent change. That's what the terminology is. So recent change verify, like I said, is almost exclusively done not from the craft shell on 5ESS, but from the AppRC, although it's totally possible to do it from the craft shell. This system is reached by using the command up there, the AppRC command, which executes instantly, so you can use the exclamation point terminator. And I'll show you that, that interface later because it is part of the training simulator, but a lot of the cool screens, like where you can add call forwarding and other features, are missing from it, unfortunately. Yeah, kind of what I just said. Also, the training simulator does provide a craft shell prompt, but almost every command just comes back with NG, no good, because they actually have this little video walkthrough with this, like teenage guy named Justin who just got a job and this older guy named Bob walking him through, how to, it's hilarious. And they're like talking, it's actually a Win16 app. So it was like for Windows 3.1. So it's quite dated. But yeah, the documentation and the simulator are pretty cool stuff to have. Oh, I'm sorry, did I say that I should have, instead of MCC interface, that should say STW or STLWS or TLWS. TLWS is trunk line workstation. S in front of it is secondary or, yeah, I believe it's secondary. So adding call forwarding to a line, if you wanted to be, 935-1337, you would simply pick that line and add, oh, I'm sorry, I put CFA. That's on the DMS 100. It's CFV is the feature you would add to your line. And you can actually bounce it through several lines, but that doesn't really help. ANI is still getting broadcasted, but it does spoof call forwarding, so you can also use it to call out. You could set up a ghost line that calls somebody else, call through it, and caller ID would show up as you calling from that number. But it doesn't do anything for ANI. Unless something has changed in the last few years. So you can also take a look using the AppRC menu system at the different trunks that the switch connects to. This is even easier to do on the DMS100, which has a table editor where you can just dump out the table. In the menu system, you have to kind of go one by one through each trunk or trunk group. So there's interLATA stuff, which are long-distance carriers, like AT&T. I guess they don't do just interLATA anymore. And MCI used to, like all the 1010 operators, that's interLATA. DNs are directory numbers. So you can tie a directory number to a trunk. And a trunk is not always an interLATA carrier. It's not always even out of the switch. And I'll get to that later when I talk about wiretapping. But for spoofing ANI, what you would want to do is tie a DN to an interLATA carrier and use what's called the delete digits feature, which is used usually for direct inward dial. Do you guys know what that is? Like if you have, I see Michael saying yes. If you have, a company and you want, you want extensions. You have like extensions 5,000 through 6,000, and you want to be able to dial, 555, 5,000, and 37. You would set delete digits to delete the first 3 digits, so that the PBX, the internal PBX, would just have the extension, and it would go directly to that person. So you can use that to delete all the dial digits, and then use what's called the prefix digits, which is another feature used for, direct inward dial, to add the number that you really want to dial. So you delete all the digits that you dialed, which are the digits of the directory number tied to the trunk, and then you insert a new number, which is the number you want to dial long distance, and bill it to some other number. It doesn't even have to exist. The SS7 network is totally open. It does not, it's closed network, but as far as authenticating the numbers you send for ANI, it doesn't, interLATA carriers aren't looking and saying, oh, this came from this switch owns these prefixes and phone numbers. So anything outside of that range is, no good. No, you could bill a call to 1111111, and they would totally accept it. They just wouldn't be able to actually bill anybody for it. I'm not encouraging that either. So. Did I cover that? Yeah. Okay, so wiretaps on a 5ESS. You have to set up what's called busy line verification using what's called a no test trunk. No actually stands for number. There was a big argument between Eric Bloodaxe and a friend of mine on whether it was actually pronounced no test trunk or number test trunk. I prefer no test trunk. You also have to set up what's called the test position. I am actually leaving out one step that's required to set up a wiretap. I don't really encourage /hacking, so you'll have to figure out the last step for yourself. But these first two will get you close. And if you look at FirmGrasp's article, he talks about the same. He talks about the same thing and how to tear down those, which is basically using, instead of set, use DISC for disconnect, and then give the test position number. So yeah, he also in his article, which is like the best article on 5ESS that's been written to date, didn't give the full information for wiretaps, and I agree with that. So you'll know you've correctly figured and set up a wiretap on a 5ESS when the target number goes off hook and you get a call on your test position number. Like, you'll just get rang. It could be your cell phone, it could be any number. And if you set it up in talk and monitor mode, you can actually participate in the conversation. You can listen to the dial digits as well, and decode the GTMF if you want. So it can be set to monitor or talk and monitor mode. So I guess, yeah, getting into the craft shell and how to escape to a root-born shell. The craft shell is already running as root, but it is not, you can't just escape out of it by issuing the standard command to execute a shell, which is RCV menu sh, as opposed to apprc, because there's a password involved. So the password is actually stored in etc password. It's for the user sh dash. That's not a typo. However, if etc password is not there, there's no password prompt, and you're instantly put into a pound shell. I'm not giving the command for that either, but it basically just does it's a rather long, rather arcane command that just basically does an mv etc password. I always use /temp/rr, and then once you get root, you just move the password file back. There's only about 7 users in there anyway, and they're not logging in like a lot. So it's not like you're going to, it's not like anybody's going to notice that they can't log in the 2 seconds it takes you to replace the password file. But they might notice on the ROP, and that ended, well, that can end up badly. So also, security issues with 5ESS. Coming from an X25 or datakit network, which means you've already penetrated the telco, you have absolutely no authentication to the 5ESS switch. DMS, this is different. There's authentication whether you're on modem or dial, or on datakit or on X25. You get instantly dropped to that prompt I showed earlier, rep CFT shell terminal in service, and bam, you're powerful. And since you're already on the X25 or datakit network, chances are you own every 5ESS switch that RBox has. Yeah, like the command I was talking about earlier to escape the password prompt, there are tons and tons of commands on the 5ESS craft shell that bypass the sort of restriction placed on accessing the born shell. There's file copy operations. You can list the contents of directories. You can list the contents of files, probably even write to a file, although I don't think so. But you have to know the commands, and the only way to do that is by obtaining those input manuals, or just the input manual would be enough, obviously, but the output manual significantly helps. And they are very hard to get nowadays. I had one back in 2000 and lost it to something, and it took me almost 10 years to get another copy. So, oh, the file system. There's something very interesting about the 5ESS file system, is that it uses something called the extent bit on certain files. This is the X in the first column where you would see a D or an L for, like a symlink or a directory. It means that most of the blocks of the file are contiguous. So I thought I'd point that out and you know, I don't know if anybody's seen that before, because I haven't heard of anybody else that has actually seen that on another system. So if you have, I'd love to talk to you because it's kind of interesting. But I know newer file systems are using the extent feature with, I think, inodes. I'm not sure if they're using it with data blocks. Just kind of browsing the web the other day and read about a little bit of it, but I don't know a ton about what's going on in the modern community of file systems with extent. So, most of the craft shell commands are single, no, not really always single, are binaries in the /cft bin directory or /cft shl directory or some other subdirectory of that. So you can actually invoke those directly from the Bourne shell. So it's possible to even do recent change from the Bourne shell, because you can do it from the craft shell, and you can invoke the craft shell binaries from the Bourne shell. That would even arouse more suspicion when people got to reading the printout from the receive-only printer, which they do. I guarantee you they do. I know firsthand they do. So Etsy is where init, login, and other binaries, like what would be in SBIN today, live. Etsy BWM is where, I forget what BWM stands for, I would usually know it, but it's where software updates are done, where you upgrade to a new generic. A generic is a software release of the 5ESS system. So like 5E14 is the 14th generic, is the 14th release of 5ESS, the 14th version. Other directories, these are simply interesting to Google for if you're interested in 5ESS stuff, because interestingly enough, just Googling for 5ESS information, using the word 5ESS will usually only bring you, the only good thing it will really bring you is Firm Grasps article or maybe a couple other articles that have some information on the 5ESS. But if you include something that actually appears on a 5ESS switch in your query, you'll find stuff in telco websites like nominal logs from switches and stuff like that. So yeah, if you Google for like N05 text, you'll hit a bunch of 5ESS stuff. So I already talked about falloc and the extent bits. Also, dmert, did I say what Unix RTR is? Dmert is the old name for Unix RTR, which is Unix Real-Time Reliable, which is the OS that runs a 5ESS administrative module. The communications module is what's used to connect the administrative module with the switching modules. Interestingly enough, if you simply RM'd a switch or killed all the processes on a switch, you wouldn't stop people from making calls. You would stop them from making possibly inter-LATA calls, long-distance calls, and you would stop all automated message accounting, which would stop all bill dating, or bill data for the bill data system that telcos use. But it's not like when you pick up your phone. When your phone goes off hook, a process on the 5ESS administrative module, a Unix process doesn't kick up and start listening for, whatever you're dialing or something. It's not like it works like that. It's handled by the switching modules. So there's a general purpose debugger called GRASP, which stands for Generic Access Package. Language is very similar to the MML language used for craft. It actually is invoked, all the GRASP commands are invoked from the craft shell. So it's pretty arcane. But I know a few commands. I think they're coming up. Yeah. So when a friend of mine was on a switch, they didn't know how to. There was no UUD code, and they were on a 7-bit connection, hopping through a modem that was on 7E1, and then to X25 network, and then to a datakit terminal, and then to a switch. So they didn't know how to upload binaries. And furthermore, they didn't know anything about the ABI or the machine code or assembly of the Western Electric 32K processor, which is why I recently purchased a 3B2, and I will show some of that later in the presentation. Because the 3B2, excuse me, I'm going to get a drink actually. Sorry. The 3B2 uses the same processor as the 3B20. Oh, I knew I'd run out of time. So I'll start burning through these. So you can dump kernel memory, you can dump user memory, you can dump or you can copy data from main memory to a utility variable, or to a register, or to main memory. And you can display a register. The registers are named R0. The general purpose registers are named R0, R1, etc. And you can load binary stuff into the GRASP using / 3-digit octal escape codes. So assuming, and I believe there is a write out command, that a write out command exists after you've loaded your data, you could create a binary file, even over a 7-bit connection. It would just take a fucking long time. Okay, so you want to see who's been calling somebody, or who somebody's been calling, or you want to trace the call. The first command outputs the incoming line history block, which will, did I say status block? Line history block. It gives you the last number dialed, and it'll actually tell you if the *67 flag was enabled, because the *67 / blocked line flag is passed from the beginning switch all the way to the switch that terminates the call to the in subscriber. Also, you can get the output history. I'm sorry, it's OLHB, not OHLB. I apologize about that. And IPC TRC traces a call in progress, which you can also do with op ILHB. I mean, it's just going to print out the number that's currently talking to whatever number you're going to trace with IPC TRC. But I guess they felt the need for 2 commands for that. All of these parameters take a DN parameter or an LEN parameter, which is LEN is line equipment number. DN is like logical address for your phone. That can be switched anytime. The equipment number is like the physical address. And it's in that format right there. Okay, DMS 100, also known as the supernode. It's manufactured by Nortel, which is now going south. But the DMS will be around for a long time because it's in so many places, and it's a very useful switch. I'll cover some of the useful tables in the table editor, servboard, CI. Actually, you know what? I don't think I have time to do that. Actually, I think I ripped those slides out, and because I knew I wasn't going to have time to do that, I'm going to just cover the most useful stuff on DMS, which are the most useful tables, and using the DMS debugger to capture passwords of users with higher privileges. So, useful tables. Table CLIGN contains all the numbers that have calling line identification on them. This will include, of course, the modem dial-up to the switch if one exists. Table OFRT is the office routing table. Table CLLI is the trunk and trunk groups attached to the switch. Table DNI&V is the directory number inventory table. It's possible, again, on a DMS, just like on a 5ESS, to tie a directory number to a trunk on the switch. And this is particularly useful for wiretapping on the DMS, because there is a, if you go through table CLLI, you'll actually see a modem. I think it's dmodem is the name of the trunk, or the silly name, which is not actually a real silly name. And if you attach a DN to that, you can actually dial into an internal modem on the switch, although it doesn't respond to anything. I don't know what the hell it's for. And then the other really interesting internal trunk is VER90, which is like busy line verification. It's a verification trunk. It's used basically to do wiretap. So if you tie a directory number to VER90, which I'm not going to explain exactly how to do, but it's very easy. And you can do it in multiple ways. You can do it in a way that statically attaches the number you want to listen in on, or you can do it in a way where you can actually dial up the VER90 and MF the tones of the number that you want to listen in on if that number is served by that switch. I prefer the latter because then less data stored on the switch, and I mean, my friend prefers the latter because there's less data stored on the switch. So, DMS 100 privilege escalation using the debugger. I have to thank Mark Abene for this, a good friend of mine, fiber optic. He schooled me to the debugger to look for interesting things. And this is a way to capture passwords of every user that logs into the switch. You set a trace point on a certain function in a certain module. I'm not going to put the name of the module and the function in there for the same reasons that I didn't do the other stuff. But once you have that trace point set up, you use this subcommand here, which is DI, stands for dump info, L as in local, aka stack, N as in N equals 255 as in 255 bytes in char. And then you come back later and see a character dump of the stack, which includes usernames and passwords, including those of higher privileged users, and almost every user on the switch has access to the debug command. So it's like you know, having access on a Unix box to logging every strcmp and bin login. Okay, DataKit VCS2, it's a virtual circuit switch network. Many telcos are migrating to TCP/IP using this ComKit product, which is basically a dual homed host with DataKit on one side and Ethernet or TCP/IP on the other. You telnet into the Ethernet side, it presents you with a destination prompt for DataKit. DataKit into the DataKit side, and it presents you with a TCP destination. Identifying a DataKit terminal server. You see any of those strings. You probably won't see network access password. I haven't seen that in 15 years. After logging in, you'll be presented with a capital destination prompt with a colon followed by exactly 2 spaces. And addresses are in the form of area/prefix/hostname, and then an optional .service, which is also a string. So there's actually no DNS. Name resolution is much closer to the center of the network, which is one thing I like about DataKit. On Unix hosts with the DataKit interface and stack, to dial out, you simply use the dkcu command, which is like cu, if you're familiar with that. It's like the call-up command for dialing out on a modem. I put something funny in here, dkcu Russia/Moscow/Kremvax. And that would connect you to the VAX in the Kremlin running DataKit. So thank you for your time, and I am done.